Right, so let's talk about how we can detect ARP poisoning attacks. First of all, let me show you the ARP tables. So in our Windows device, which is the device that we always attack, I'm going to run a command, ARPA, to list all the entries in the ARP table. So each computer has an ARP table, and that table associates IP addresses with MAC addresses. So we can see the IP address of the router, which is 10.20.14.1, is associated with the MAC address 52.54, and it ends up in 35.00. So this is the MAC address for the IP for the router. So the way that ARP poisoning works, like we discussed before, is it works because each request is trusted, and clients accept responses even if they didn't send a request. So what the hacker does is he sends a response to the client telling them that they are the router. So the client will accept that, it will trust it, and it's going to accept the response even though it didn't send a request. Then we'll send another response to the router telling them that we are the client. So what this is going to do, it's going to modify the entries in the ARP tables in both in the router and in the client. And for the client, it's going to contain the hacker's MAC address, and it's going to associate that with the router's IP address. So what's basically going to happen is it's going to modify the MAC address here, and it's going to change that to the attacker's MAC address instead of the router's real MAC address. So when that happens, then the hacker will be in the middle of the connection, and they'll be able to read, analyze, and modify the packets because they're going to be flowing through the hacker device. So let's run the ARP poisoning, a normal ARP poisoning attack like we always do it. And when I go back here, I'm going to execute the same command. So I'm going to do an ARPA again. And note how the MAC address is going to be different. So the MAC address for the router, it used to be this one. And when we ran the command, then the MAC address changed to this one. And this MAC address right here is the MAC address of the network card that the attacker is using. So if I come here and just do an ifconfig, you'll see that this is the MAC address, the same MAC address that is displayed in here. So this is the easiest and the simplest way to discover ARP poisoning attacks. It's not the handiest way though, because you're going to have to keep doing this command and keep comparing the entries if you really wanted to check if you're being ARP poisoned. So there's a tool called XARP, and it does that automatically for you, and it's available for Linux and Windows. So I already downloaded. You can just Google XARP and you can download it. Very easy to download and install. And I'm just going to run it. I'm actually going to stop the attack first, and then I'm going to run the tool. Now notice when you stop the attack, the IP address is going to go back to what it was. So you can see that the MAC address of the router is back to its default right value of the router. So I'm just going to run XARP now. And you can see that everything is good. And you can see that the entries are very similar to what we did when we did ARPA. So we have the IP addresses and the MAC addresses associated with it. What the tool basically does, it's just going to automatically monitor this. And whenever something changes, it's going to know that something's wrong is happening because each IP address should have a unique MAC address. There should be no duplicates in the network. So I'm going to do another ARP poisoning attack exactly like we did it before. And when we come here, you'll see that XARP is giving us a notification and telling us that something's happening. It's telling us that the MAC address for the router, which is the 10.20.14.1 IP, has changed from this to that. And if we look here, I'm going to click OK. And if we look here, we can see that the affected machines are the router, my own machine right now, and the attacker. Sorry, that's me, and that's the attacker. So basically, we know that the machine at 10.20.14.203 is trying to do an ARP poisoning attack because it's the one that the router's MAC address has changed to. Therefore, we know this is the attacker machine. So this tool is really handy because it does the monitoring automatically for us, and it will tell us whenever someone is trying to ARP poison the network. Okay, so now let's see how we can use Wireshark to discover suspicious activities in our network. And before I do anything, I'm going to go to the preferences. And I'm going to go to protocols, ARP. And I'm going to enable the option to detect ARP request storms. What this will do, it'll actually discover if anybody is trying to discover all the devices on the network, and it's going to give me a notification. So I'm going to click on OK, and I'm going to start my capture. And now I'm going to go to my Kali machine, and I'm going to use NetDiscover. So I'm not going to do ARP poisoning. I'm only going to try to discover all the connected devices to my network. So we're using exactly the same command that we used before, NetDiscover, interface, and the range. I'm going to hit enter. And we can see that NetDiscover finished. It discovered all the devices that we have. So if we come here, even before we look at the output of the notifications, let's just look at the packets that have been generated. You can see that there's a device here. This source is broadcasting, so basically it doesn't have a destination. It's asking all the other devices in the network, and it's inquiring about each possible IP. So it's basically asking who has this IP and tell the 67 IP, and then it's asking who has the 241 IP, tell the 67, who has the 251, tell the 67. And it's doing this for every possible IP. So it's basically checking if any possible IP in the range exists, and it's asking to return the response to the IP at 10.20.14.67. So from this, we can deduce that someone is trying to discover all the connected devices, and that someone is at 10.20.14.67. Now, if we go on the Analyze and Expert Information, you'll see that we detected an ARP packet storm. So basically it means that there was a single device sending a very large number of ARP packets. So they're probably trying to discover connected devices or trying to discover connected ports. So it's telling us that this person is trying to do something suspicious. Now let's go, and I'm gonna do a ARP poisoning attack, and we'll see if we can get any notifications or warnings in Wireshark. Now I'm going to go to Analyze and Expert Info again. And if we look, we'll see we have a warning here. And the warning is telling us that there is a duplicate IP address configured. So again, this is telling us that the IP address of the router had two different MAC addresses. What this means, basically, it means that someone was tampering with this and tampering with our ARP table, trying to place themselves in the middle using an ARP poisoning attack. Now, we've seen a number of methods to detect ARP poisoning. Let's discuss how we can prevent it or protect ourselves from it. Now, I'm just going to run an ARPA, and we're going to look at our table. There is switches that will monitor this for you as well, and they'll notify you or even prevent ARP poisoning attacks. Another way to do that is, if you look at here, if you look at your router, you'll see that this entry in the table is dynamic. So the type of this entry is dynamic. What that means, it basically, this can change. It's the system allows this value to be changed. You can see right here, you have static values, which basically means the system will never allow these values to change. So you can use static ARP tables, which basically means that you'll have to configure each IP address. So you have to actually configure your ARP table and map each IP address to the MAC address, to the relevant MAC address. But once you do that, even if someone tries to send a response to your computer trying to change it, the system will refuse to change anything because you configured your ARP table to be static. The only problem with that is every time you connect to a network and every time there is a new device connecting to your network, you'll have to manually configure that device to work with your network. So it's not a very useful solution if you're in a big company or if you're in a big firm, but maybe in a small house or in a small company, then this would be a really good solution to prevent ARP poisoning attacks, because everything is going to be static. You're going to have to set it up manually. But when someone tries to do an ARP poisoning attack, even if their attack is successful and they use the best tools they can, your table is set up in a way that it's fixed. It can't be changed. So the system will always refuse to change the values of the MAC addresses, which will basically mean ARP poisoning attacks will never work against you.
In the previous lectures, we learned how to detect ARP spoofing attacks by manually analyzing the ARP tables. We also learned how to install tools such as XARP to automatically detect ARP spoofing attacks without having to manually check the ARP tables. And we even learned how to detect other suspicious activities using Wireshark. Now, this is really good, but still has a few problems. First of all, we're only talking about detection. So even when we detect that someone is intercepting the connection, we can't really do much. All we could do is simply disconnect from the network, maybe change its password if we can, if we own the network, to something that's more difficult, or if this is a public network such as an airport, a hotel, or a college network, then all we can do is simply just disconnect and use a different network because we can't change its password. The other problem with the previous methods, like I said, they're only detection methods. Therefore, they'll only work if the target managed to become the man in the middle using ARP spoofing. But what if someone is able to intercept the connection using another method? For example, if someone is running a fake access point, like I showed you earlier, and you connect it to this fake access point. Or if you connect it to a hotel, a college, a public Wi-Fi network, a cafe network, and the admin of that network is actually collecting data, or someone or a hacker gained access to the admin's computer and again is analyzing the data. Because by default in fake networks and in any network, the admin is able to see the traffic because the traffic will have to go through their server or through their router. So the detection methods that I showed you earlier won't even work against this. Therefore, in this lecture, I want to discuss two solutions to this problem. So the idea is you use these solutions if you discover that you're being attacked, or if you're connecting to a network that you don't own and manage yourself. So if you're connecting to a college network, an airport network, a cafe network, or any other network that you yourself don't have control over. The solution to all of this is to encrypt your traffic. If you encrypt your traffic, we don't really care if somebody is able to intercept this traffic because our traffic is going to be encrypted, therefore it'll be gibberish and it won't be useful to anybody that is intercepting our traffic. So there are a number of ways to do this and I'll explain how they work as we go through it. So let me show you this in action. Right here, I'm already running BetterCap, and as you can see, it's already getting information. And right here is my target, and we're already on VulnWeb. And if we just click on anything just to show you, you'll see the domain is going to be detected in here. And then let's just quickly log in. You'll see this login attempt will be detected. So we have the username is admin and the password is test. Again, if we try, I'll just open a new tab and go to Stack Overflow. You'll see it'll load over HTTP, not HTTPS. So again, if I go ahead and log in, I'll be able to log in and detect the password. And the HSTS method that I showed you earlier, again, it'll work and we'll be able to bypass that and steal the password. So right now, this Kali machine is able to intercept all the data that is sent to and from my Windows machine right here. So the first method to prevent these attacks, so we don't care if we're being attacked. Again, I'm not running XARP, I'm not managing my ARP tables. I don't care if someone intercepts my data. What I'm going to do is I'm going to install a plugin on my browser called HTTPS Everywhere. So I'm going to be installing it on Firefox. I'll include its link in the resources of this lecture, but there is an equivalent of this plugin for most browsers such as Chrome and others. All you have to do is simply click on Add to Firefox or Add to Browser, whatever browser you use. We're going to click on Add in here. And that's it. The plugin is added in here. As you can see, we're going to click on OK, and we can manage it here from its icon on the top right. So as you can see right now, it's set to off. And if I click this, I will turn on this plugin. And basically what this plugin will do, you can think of it as if it adds HSTS support to more websites, pretty much to any website that uses HTTPS. Therefore, for example, when I tried to access Stack Overflow in here, I was able to downgrade it because my browser does not know that this website should be loaded over HTTPS, and BetterCap was downgrading the HTTPS requests to HTTP, like I explained in previous lectures. What this plugin will do, similar to HSTS, it has a list of websites that support HTTPS, and therefore, when we try to downgrade the HTTPS connection of this website to a HTTP connection, it'll tell the browser, no, don't do that, and it will upgrade it again back to a HTTPS connection. So let me show you. I'm just going to delete the history, and I'm going to load Stack Overflow again, and perfect. As you can see, it's loading with HTTPS in here. Therefore, now if I go and log in, my information will be encrypted, and therefore the hacker won't be able to see my username and password. So that's really, really good, but not perfect. Let me tell you why it's not perfect. First of all, if we go back to a HTTP website, again, similar to what we have in here in VulnWeb, so I'm just going to log out. And we'll log in again with another password. I'll just put the password now to 12345678990. We'll log in. And if we go back here to the logs all the way down, you'll see we are still able to detect the username and the password. So this plugin is really good for websites that support HTTPS. It'll force us to load HTTPS on websites that support HTTPS. But if you access a website that only uses HTTP, such as VulnWeb, I know there aren't a lot of websites that do that, but they still exist. So if you access any website that uses only HTTP, then that website is still open to the hacker. So the hacker can still see this information. They'll still be able to steal usernames and passwords if you send usernames and passwords to them. Not only that, but they will also still be able to replace downloads, serve you fake updates, or inject JavaScript code like we seen earlier and get you hooked to beef. HTTPS Everywhere also does not prevent the hacker from seeing the websites that you access and running DNS spoofing attacks. Let me show you. So if I just go to bing.com, for example, and then let's go to duckduckgo.com. Keep in mind, HTTPS Everywhere is still working, and let's go to the hacker machine and just look at our logs. So as you can see, we can still see that our target went to DuckDuckGo. We can still that the target went to Google. We can see that the target went to Bing. So we can still see the domain names, but we can't see the data that gets sent because that will be encrypted with HTTPS. So there is still some data that the hacker is able to get. If you want to take your security to the next level and completely encrypt everything you send and receive, then you should think about using a VPN. Therefore, in the next lecture, I'll explain to you what a VPN is, how it works, and how it can protect us from hackers or anybody that intercepts our connection. In the previous lecture, we discussed a good solution to protect us from man-in-the-middle attacks, and that solution was to use HTTPS Everywhere plugin. With this plugin, as seen earlier, we were able to force all HTTPS websites to always load over HTTPS. Therefore, if anybody intercepts our data, it'll be useless because it'll be encrypted with HTTPS. So this solution is really good. It's free. The only problem is, as you know, it only works with websites that use HTTPS. So we seen earlier, if you log in or use a HTTP website, your data is still exposed. Hackers or anybody that intercepts your data is still able to read your usernames, your passwords, or inject JavaScript code, serve you fake updates, and so on. Also, as seen earlier, with this plugin, the hacker or anybody that intercepts your data will be able to see the websites that you visit. Not only that, but they'll also be able to manipulate DNS requests, and therefore they'll be able to run DNS spoofing attacks. At the end of the previous lecture, I said if you want to take your security to the next level, then you should think about using a VPN. Let me show you what happens when we use a VPN, and then I'll explain it in more details to help you understand what's happening. So I'm back here at my hacker machine. As you know, it's already the man in the middle. I'm going to clear the screen, and I'm actually going to even turn off HTTPS everywhere. Now, it's a good idea to use both at the same time, but I'm just going to turn it off just to show you the difference. You can use any VPN provider you want. It really doesn't matter. Most of them use more or less the same technologies. We at Z Security provide our own VPN service called ZSVPN. So I have it right here. It comes with no logs. We support all operating systems, Linux, Windows, OS X, Android, and iOS, and even Tails, which is a privacy-focused Linux distro. So, like I said, you can use anything you want. They all use more or less the same technology. What I want to highlight right now is what happens when you actually go ahead and use a VPN. So I'm going to open my client and I'm going to connect to a server, one of these servers right here. And what this will do is it'll establish an encrypted tunnel between my computer and the VPN server that I just connected to. Therefore, right now, let me show you. Let's just start. I'll delete everything. And let's start by going to some websites. For example, we'll go to google.com. Then we'll go to bing.com. And then let's go to Stack Overflow and make sure it loads over HTTPS. Now, keep in mind, I am not using HTTPS everywhere, but you'll notice that it'll still load over HTTPS. As you can see, we're not able to downgrade it. And let's take this even one step further. Let's go to vulnweb.com and just log in. So again, this is a website that only uses HTTP. It simply does not support HTTPS. But let's log in and see if we can still capture the data. So I'll just put my password now, 0987654321. Log in. And let's go back to our Kali machine to see if we detected anything. Now, as you can see, we're not able to read any of the traffic sent to and from the target. So with the case when we used HTTPS everywhere, we were able to see at least the domains, the websites that the target visited, and we were able to see data sent over HTTP when we logged in to vulnweb.com. But in this case, as you can see right now, we can't see the username and the password even if they're sent over HTTP to vulnweb, and we can't see the domain names that the target visited. And the reason for this is because we are using a VPN, and like I said, a VPN creates an encrypted tunnel between our computer and a server, and all of our data will be sent through this encrypted tunnel. Let me explain this to you with diagrams to make it simpler. So, in general, let's say you try to go to google.com. Your connection will pass through a number of hops, but at the end, it's going directly to google.com. Hence the red arrow indicating that this connection could possibly not be encrypted, therefore your data might be at risk. Now, when you use a VPN, you connect to a VPN server in a certain country. And when you do that, you create an encrypted tunnel between your computer and the VPN server. So let's say you want to go to google.com. That request will first be sent to the VPN server. Now, the VPN server will be able to read this, but the data is sent in an encrypted tunnel. Therefore, if anybody intercepts this data, they will not be able to see what you are sending to your VPN server. That's why we don't even care if someone manages to intercept our connection, because our data is simply gonna be gibberish to them, as you can see in here. Then, once the VPN server receives your request, it will forward it to the destination that you're requesting, and the response will follow a similar route. Now, because of this structure, because of the way that the data is always encrypted between you and the VPN server, using a VPN can be useful in so many scenarios, because it adds an extra layer of encryption. Therefore, it improves our privacy and anonymity in general. It allows us to bypass censorship, because let's say your internet service provider is preventing you from accessing certain services or certain websites. They will not be able to know what these websites and these services are, because again, the connection is encrypted and they won't even know what you're doing. All they'll see is that you're connecting to a server in some country. And last but not least, it'll also protect us from hackers or anybody that intercepts our connection, again, because all of our data is encrypted. Therefore, we don't really care who intercepts this data. The data will be gibberish. Now, also because of this structure, you need to be careful when you pick a VPN provider, because this structure introduces the VPN provider as a man in the middle. So as you can see, we send everything to the VPN server first, and then it goes to the internet. And the VPN server is able to decrypt this data, because the tunnel, the VPN encryption, is only used between our computer and the VPN server. So if the admin of the VPN server wanted to analyze your data and see what you send and receive, they will be able to do that. Therefore, you need to make sure that you pick a reputable VPN provider, a company that you can trust. You want to stay away from free providers, because providing a VPN service is very expensive. Therefore, if someone's able to give it to you for free, they must have another angle or another reason of why they are giving this for free. You want to make sure that the VPN provider keeps no logs. And with all of that, you can use HTTPS Everywhere plugin with the VPN. If you do that, you will actually fix the problem of the data leaving the VPN server, because your data will be encrypted between your computer and the VPN server with 2 layers of encryption. First, using the VPN encryption, and second, using TLS because of HTTPS Everywhere. Then, data leaving the VPN server will be encrypted with 1 layer of encryption, which is the encryption enforced by HTTPS Everywhere. Therefore, even though the VPN provider is able to see your data and able to decrypt the encryption used in the VPN tunnel, they will still not be able to see your data, because it will still be encrypted with TLS. So this basically solves the problem of the VPN server being able to see your data, because at the VPN server, your data will still be encrypted with TLS. So, to summarize the 2 methods that we covered to protect our data from man-in-the-middle attacks, with HTTPS Everywhere, it's great, it's free. The only problem is it only works with HTTPS websites. The person intercepting the data will still be able to see the websites we visit, and they will still be able to run DNS spoofing attacks. Then we spoke about using a VPN, and with using a VPN, everything gets encrypted, so that's even better. None of the attacks that we talked about and that we covered in this course will work, because everything gets encrypted. The only problem is it's not free. There are free services, but like I said, they're not great, so you shouldn't use them. Just don't use a VPN if you don't want to pay for it. The other problem with the VPN is that the VPN provider can't see your data, so you're introducing a man in the middle. But we can take this one step further and use HTTPS everywhere with a VPN. And with that, we're getting all of the benefits of using a VPN, so everything gets encrypted, protect us from all man-in-the-middle attacks, but without the problem of the VPN provider being able to see our data, because our data will be encrypted with 2 layers. Therefore, even the VPN provider will not be able to see what we send or receive, because it'll still be encrypted with TLS. So the only downside to using HTTPS everywhere with a VPN is the fact that you have to pay for the VPN service.